In this video, we're going to take a look at Gay-Lussac's law. And we're going to look at the relationship between pressure and temperature for a gas. So let's take a look at our simulation. And on our simulation, what I'm going to do is I'm going to keep volume consistent. So I'm going to lock this here to make sure that the volume always stays at this 677 liters, right? And I'm going to take a look at what the temperature is at the moment. It is 220 Kelvin and the pressure is 0.8 atm. So if I increase the temperature, I'm wondering what is going to happen to my pressure. So if I increase my temperature, when temperature increases, pressure seems to increase as well. Well, what if I decrease temperature? When I decrease temperature, pressure seems to decrease as well. So this can be summarized by Gay-Lussac's law. So pressure and temperature are directly proportional. Again, I can express this by writing this. Pressure is directly proportional to temperature. And I can summarize this by writing the formula, which is P1 over T1 is equal to P2 over T2. I can also write this, again, this is just a different version of the same formula rearranged. So P1 times T2 is equal to P2 times T1. Either one, whatever works for your calculation. So why is it that an increase in temperature results in an increase in pressure? So particles, when they have more temperature, like we talked about in the previous video, have more kinetic energy, which means they move faster and collide more often. And when this happens, when they're colliding a lot and they're moving a lot, there is an increased pressure exerted on the container, right? And when there is a decrease in temperature, there is less kinetic energy, which means the particles move more slowly, which results in less collision and a decrease of pressure exerted on the container. Right? So when you increase temperature, pressure increases. When you decrease temperature, pressure decreases. It is a proportional relationship. Let's take a look at a calculation problem. So the pressure of the oxygen gas inside a canister with a fixed volume, so notice that, so I'm realizing that the volume stays consistent, is 5.0 atm. So I know that the initial pressure is 5.0 atm at 298 Kelvin. So I'm given my initial temperature as well, 298 Kelvin. What is the pressure of oxygen gas inside the canister if the temperature changes to 263 Kelvin? So there is a new temperature, T2, 263 Kelvin, and they're asking us to find the pressure when the temperature is 263. So pressure P2 is equal to question mark. Now let's take a look here. Temperature seems to decrease. So that itself should give us a hint as what is going to happen to this pressure, right? Because temperature decreased, pressure should decrease as well. But let's actually calculate and find out what P2 is going to be. I'm going to start off with my formula. P1 over T1 is equal to P2 over T2. In solving for P2, I need to move T2 over to the other side. Right now it's being divided. When I move it over, it's going to be multiplied. So P1 times T2 divided by T1 is going to give me P2. Plugging in all my numbers, 5.0 atm is P1 times T2 is 263 Kelvin divided by 298 Kelvin is equal to P2. Reminder that for temperature, you need the temperature to be in Kelvin. So if this was in degrees Celsius, you have to first convert it to Kelvin, then plug the numbers into my formula. Now the Kelvins to cancel out. And when I plug these numbers into a calculator, I'm going to end up with 4.4 atm. Why is it atm? Because that's the only unit left over. And it's two significant digits because if I take a look at all my numbers, 5.0 has the least number of significant digits, and that is 2.